Okay, hi everybody. This is another video lecture for first year Maths for Managers and for first year Business Maths 1. And the topic is a new topic. The topic is probability. And it's not a very long section. People tell me that this is, whenever I give lectures, live lectures, and I'm in the room with people, they always tell me that this is something that they feel they understand and that they feel very comfortable with. But I find that overwhelmingly this is answered worse than I would usually expect, given that kind of response from students. Okay, I think this there's no reason that this should be unnaturally difficult. In fact, I don't think it is unnaturally difficult, but I do think it's something that people have a tendency to struggle with, and I'm going to try as best I can to teach this in a way that will avoid those difficulties. But if you have any questions, please let me know. So I'm reading the notes that are up on the Moodle page. As a reminder, I didn't write these notes. Okay, they're legacy notes, but the content is quite good. I'll read them out here. It says probability is a concept that most people understand naturally. Now that is the one statement I think in the entire section of the notes that I massively disagree with. I would say overall most people really don't understand probability very well at all. And it says here, as words like chance, likelihood, possibility, proportion, and probability are used in everyday speech, it says in the statistical sense, probability puts a well-defined structure around the concept of everyday chances, helping us to follow a logical approach to problem solving. Okay? As I said, I think there are kind of biases and kind of tendencies to think about things in a slightly wrong way that muddles people once things go beyond the very basics. So I'll try to avoid those. I'll try to make everything very clear. So as a reminder, what's an experiment? An experiment was any process which results in an outcome. Okay, any process which results on an outcome. Okay, and a variable what was a variable? A variable was something which depends on the outcome of some experiment. Okay, and that is incredibly general. Okay, it's absolutely incredibly general. An experiment could be an experimental process in a laboratory. It could be, it could be me weighing the amount of cat food that's left in my cat's bowl at the end of the night. Okay, that will give me an outcome. Okay, it's incredibly general. We talked about this in live lectures before the closure period started. Okay. So the experiment is just a very general term describing any process which is going to result in an outcome. Okay, and a variable then is something which depends on the outcome of the experiment. So for example, if my experiment is rolling a dice, okay, rolling dice, then my variable could be something like the sum of my dice roll. That would be a variable that would depend on the outcome I got. Or the variable could be something very simple like, some function of that dice roll. It could be 2 times the value of the dice roll, maybe 2 times the value of the dice roll plus 7, whatever it would be. It would still depend on the outcome of the experiment. My experiment could be choosing a person at random from the population. Okay, then the outcome of that experiment is an individual that I select. Okay, and a variable could be that person's height, that person's weight, that person's favorite color. Okay, so incredibly general terms. It's almost difficult to see how they could possibly be useful because they're so general. But the generality is important because otherwise it simply wouldn't apply to such a broad collection, a broad spectrum of problems and applications in the real world. Okay, so, and we said that a probabilistic variable is a variable which has some dependence on chance. Dependence on chance. Okay. So a probabilistic variable, for example, could be something like the roll of a dice, a card selected from a pack, but it could be something like, it could be something which depends a little bit on chance, but also on some other factors too. So, for example, the amount of money that I would get paid at the end of the month might depend on chance. If suddenly there was an event that would result in greater taxation, or if I had to miss some days because of work, some days of work, which is a situation we're all very concerned about at the moment. But if I miss some things, then those would be probabilistic events which would affect the amount that I would get paid. But there's also an element of determinism in that it would be, if I have a salary, it will usually be very similar month to month, calculated from the same base rates and so on. So there can be some dependence on chance, but some dependence on other things as well. But a probabilistic variable is one which has some dependence on chance. Okay, so very, very broad, almost seemingly impossibly broad. And the only term I want to introduce here for the moment is that the set of all outcomes of some experiment is called and this is the term here, it's called the sample space. Okay, so that's just a technical term, and it just means the set of all possible outcomes. Okay? So it's all outcomes for some some experiment, all possible outcomes for some experiment. So let's do a really, really simple example. Unlike what you might be used to when I'm teaching, with probability I have props. I have things like dice, I have decks of cards, and so on. So for example, let's say for example that I am rolling this die. This is a 6-sided die. It's a casino die with a, I think it's called a razor edge. This is actually an extremely unpleasant thing to hold. The corners are very sharp. This is meant for something like a craps table. But if I were to roll this die, there are 1, 2, 3, 4, 5, 6 sides, as you can all see. And the outcomes are the faces of the die. Okay, the outcomes are the faces. So this is not the number 6. This is the face of the die that has 6 spots on it. So this is the 6-spotted face. Okay. If I said then, well, what is a variable that I could associate to it? Well, then I could say the value of the roll. For example, the value of the roll for the 4-sided face is the number 4. Okay. So let's have an example here that we'll talk about. Okay. So roll a 6-sided die. And why am I saying a 6-sided die? Some of you are probably wondering, well, doesn't every dice have 6 sides? And the answer is no. If any of you have ever played Dungeons and Dragons, you know that there are 4-sided dice, 8-sided dice, 10-sided dice, 12-sided dice, 20-sided dice. Lots of different types of dice, but we'll be concerned only with 6-sided dice. And just as a little notation, if I write D6, I mean a 6-sided dice, okay? Roll a 6-sided dice. So what are my sample space? My sample space my sample space outcomes. The sample space is the set of faces of the die. Okay. So if I called that S, for example, what would I have? Well, there would be the 1-sided die, 1-spotted face. There would be a 2-spotted face, a 3-spotted face. Okay. A 4-spotted face, a 5-spotted face, and the 6-spotted face. Okay, that's my sample space. Those are my possible outcomes. Okay, and then a variable we can associate okay. What would be a variable that we could associate? Well, there's loads of them. Okay. Okay, well, a variable that I could associate with this is just I could let x be the number of spots. Okay? So then my sample space is the set of dice faces, but my values for my possible values of x are, well, then I would have the set 1, 2, 3, 4, 5, and 6. Now that might seem like an unnecessary layer of abstraction. Why can't I just say that these are the outcomes? Okay, why can't I just say that 1, 2, 3, 4, 5, and 6 are the outcomes to the experiment? Well, this is a little bit important because there are multiple variables that I can associate to any one of these outcomes. Okay, so for example, I have here selected the total number of faces, but I could also choose I could let y be equal to 0 if an even number of spots, and I could let it be 1 if an odd number. Okay. I could let it be 0 if it's an even number and 1 if it's an odd number. Okay. Which is kind of a strange thing to do. This would be kind of like an indicator. Okay. This would be another variable. And this variable only has two possible values. It has 0 and 1. But it comes from the same sample space. It comes from the same set of outcomes. Okay. Another way that I could look at this is that if I were choosing a person at random from the population, the outcome of my experiment is the person I choose, okay? And you might say, well, I'm only interested in that person's height, their weight, what they earn in a year. I'm only interested in the color of their hair, whatever it is. It doesn't matter, okay? The outcome of the experiment is the person you select, okay? Those other things are variables that depend on that person that you select. In the same way, the outcome of a die roll is actually the face of a dice, okay? The face of a die. But the value of the die roll, the standard value, is just the number of face spots, and that is a variable that I am associating to that die roll, okay? Let's move on a little bit here, okay? Now, this is not always true, okay, but actually, let me back up a little bit. So I've talked about experiments. I've talked about variables that I can associate to outcomes and things in my sample space. Okay, what do I mean by probability? Okay. Okay, and believe it or not, that is actually a question with multiple answers, and it's a question that's almost a philosophical question. So I'm going to give you two answers. The first one, okay, the first one is that probability represents the relative frequency of events, okay, in repeated trials. Okay. So probability represents the relative frequency of events in many repeated trials. So let's say, for example, this die, okay? This die is a six-sided die, like I said, D6, okay? And it has six sides, okay? And if this dice is fair, okay, that is, if it doesn't favor landing on any particular face, okay, then we should expect to see about 1/6 of the results. 1/6 of the results should be ones, 1/6 should be twos, 1/6 should be threes, 1/6 should be fours, 1/6 should be fives, and 1/6 should be sixes. Or another way of saying that is if I had thousands of trials, maybe 60,000 trials, then I would expect roughly 10,000 of each face. Okay, that in many, many repeated trials, I should get a relative breakdown according to the probabilities of the events. So if on average 1/6 of the time I get a 1, I would say that the probability of this face, of getting this face when I roll my die, is 1/6. Okay, that's one idea. Okay, I think that idea is wrong. Okay, and I'll explain why. Okay, so that's called the frequentist approach. Okay, that's called the frequentist approach, and I don't like it for reasons I'll talk about in just a moment. Okay. Okay, what is my other definition? Well, my other definition is that probability is a measure of belief that a particular event probability is a measure of belief that a particular event will occur. How would that work? Okay, well, so before we said frequentist idea, in the long run, I expect, say I roll this 60,000 times, I expect about 10,000 ones, 10,000 twos, 10,000 threes, 10,000 fours, 10,000 fives, and 10,000 sixes. And that would be the idea of the frequentist approach. Well, this idea is a little bit different. This is saying no reference to many repeated trials or anything like that. This is saying, okay, I have one trial, only one trial, okay? I look at my die. I see, okay, it has 1, 2, 3, 4, 5, 6 faces, okay? The die doesn't seem to have any particular weight. It doesn't, weighting, it doesn't seem like it would favor any particular side. It's not magnetic. It's not beveled. It's not in any way adjusted or modified that would cause it to favor some particular side. So if there's 6 sides, then I would expect that my belief is that I will get a 1. I would get a 1 with a measure of 1 in 6, okay? There are 6 possible outcomes. They all seem equally likely. 6 is one is one of those outcomes. So my measure of my belief in that one roll is 1/6. Okay? Now, I think this one's better, and I'll try to explain why. Okay? The first thing is that not every event, not every experiment can be repeated. Okay? So say, for example, you might say, well, let's go for a topical one. What is the probability that we, control the COVID-19 pandemic by the end of the year? Okay, you might say, oh, that's high probability. You believe that to be very, very likely. Okay, but the problem is we don't get a second attempt on that. Okay, it either will be or won't be. Okay, and from there, history is decided. Okay, that's different from me flipping a coin or rolling a dice, or one of my other props here. I could shuffle a deck of cards and draw cards at random. I can repeat that experiment as many times as I like. But we don't only use the term probability or chance or likelihood when we're talking about things that we can repeat. We talk about likelihood a lot of the time when we're talking about events that we cannot, that will not reoccur, that will not be subject to multiple trials. Okay, so I believe that's important. The other thing is that this is something that I don't ever really know, okay? Because we could always argue that, well, say I roll this 60,000 times and I get fewer fives than I expect. Maybe not many fewer fives, but fewer fives than I expect. Well, a frequentist could always argue that, well, just roll a few more times and you'll get more fives, okay? Which is probably true, but you're justifying with some information that you haven't yet actually developed. On the other hand, if you consider probability as a measure of your belief, which I do, then my belief can change. So for example, if I were to roll this die and every single time I rolled it, I ended up getting a 5 or a 6, okay? Well, I might start with the belief that the probability of a 1 is 1 in 6, but if I always get a 5 or a 6, I'm going to change my opinion on that. I'm going to change my belief, okay? And my belief then would be that this is modified, weighted, something like that, in order to favor these particular values. So then my beliefs can change over time. Okay, so I subscribe more to this idea than to this idea. Okay, so rather than saying, okay, a coin is fair, do I have a coin? Actually, I have coins, but I don't have one nearby. I could say, okay, a coin is fair because, if I flip the coin 1,000 times, I expect 500 heads and 500 tails. I would say a coin is fair because, it doesn't look like it has any weighting or any shape that would favor one side or the other. There's two possible outcomes. I have no reason to believe that one is more likely than the other. Therefore, the probability that I would assign is 1/2 to each of those. Okay? And believe it or not, these are completely incompatible. Okay? One of these and these are not compatible ideas. Okay. The other thing about this that is kind of important to realize is that we might say, okay, the probability of getting a 1 here is, say, 1 in 6. All right. Now maybe I roll a bunch of times. I'm getting a lot of 6s there, and maybe I do get a 1 every now and then, a 1/6 of the time, let's say. But there are events that have never happened before. Okay, there are events that have never happened before, and we still talk about the likelihood or the probability of those. Okay, so you might say, well, what is the probability of nuclear war in 2021? Okay, well, a frequentist would say, well, if I look at all of the years that we have on record, there's never been a nuclear war, so the probability is 0. I don't quite believe that. Okay, I don't think the probability is very high, but I don't think the probability is necessarily zero. My beliefs are subject to change at any time. Okay, so I would favor this definition. Okay, now here's kind of an important idea. Okay, so in either definition, a probability is some number between 0 and 1. Okay, so either probability 0 or probability 1, those are the limiting cases. Okay, and then all other probabilities must exist somewhere inside that. Okay, so what is an event? Okay. Okay. So remember that a sample space was the set of all possible outcomes. Okay. Well, an event is some subset of the sample space. Okay, so for example, let's go back to our sample space for the D6. Okay. In the sample space for the D6, I had 6 different dice faces. Okay. And an event, let's make an event A. We're going to let A be the event that we have an even face, an even number